CTF competition? All right. So wanted to firstly get started on talking before we go straight into CTF. I just wanted to talk about the two different parts of learning, right? So we're learning a little bit about theoretical knowledge, which is the learning of how to do something. And then there's the counterpart to that, which is the practical application side, which is like actually doing that something that you have just learned. And so what CTFs do is fundamentally apply the practical application side of learning so that you can actually get your hands on keyboard and then do some of these things that you have just learned. So what exactly is a CTF? So a lot of us hear CTF and we think about like we're actually going out and then like trying to capture a flag onto the field. But for most of us in cybersecurity, we hear about it in a very different sense, which is a competition or an exercise that's specifically designed such that the participants will score points by capturing these so-called flags in the competition or exercise itself. So the aim of these exercises is precisely to train and enhance your technical cybersecurity skills. So like I said, when you have the knowledge of how to do something, this is where you come and go and apply that particular skill set. So with CTS, it can oftentimes be team-based, or it can also be an individual-based competition, sort of depending on the aim of the training outcome here. So for the CTF tomorrow, it will actually be a team-based one. So you all will be able to get together in teams. You'll actually be able to see what other folks are submitting, and then your progress will all be synchronized and everything across the board for the CTF tomorrow. So what exactly is a flag then, if we're not going out and physically capturing a flag? So the flag in this particular sense is just a stand-in for some sensitive information or some important piece of information, right? So let's imagine you are a bank. Your crown jewels are your banking data. It's people's bank account balances. Maybe it's their credit card number or bank account number and things like that. So those would be sensitive information. And a flag is just a stand-in for that, because we don't want to replicate actually sensitive information, because then it would end up potentially being a little bit problematic. So we have a flag in there to represent that. And then once you have captured a flag, then that is effectively a indication that you were able to exfiltrate the crown jewels there, for example, of a particular organization. So that's why we call it a flag. So, and once you, like I said, once you capture the flag there, helps demonstrate successful recovery of that particular important data, either in digital forensics or in some sort of incident response scenario there, or you're in an offensive scenario, so maybe like a penetration testing scenario that indicates the successful exfiltration of sensitive data. So for us at Cyber Skyline, we use a particular standardized flag format. So all of our flags will look in this particular fashion. So when you play in the CTF tomorrow, you'll see SKY dash, a series of letters, dash, and a series of numbers. So that's the flag format that you will see. All of them will start with SKY dash. Any questions so far? I'm very happy to take questions, by the way. All right. So we missed something. What does the CTF look like? So if you've ever been like on a college campus and you see one of those like hackathons, which are different from cybersecurity competitions, or if you've ever seen like an actual CTF on campus, a lot of the times it kind of just looks like a bunch of people hanging out together with their heads and their laptops, because fundamentally you do need your computers in order to participate in the CTF. So a lot of times you'll see a bunch of people sort of getting together, sitting face to face, so that they can like talk with each other and get to know. You'll see some people that are, you know, talking with each other, shoulder surfing and seeing like, what are you doing? How can I help? Things like that. So it really is meant to be collaborative, and is really meant for all you need to do is just a laptop or a desktop PC, which means that if you're not at some sort of physical environment, you could also sit on your couch at home with laptop, and then you could also just participate in the CTF that way there as well. So there's really minimal requirements in terms of like getting started in a particular CTF. All you really need is just a computer. So what topics are generally covered in a CTF? there are quite a variety. Some CTFs cover a specific subsection of the topics here. Some CTFs will cover all of them. So I'm going to go over some of the ones that we generally see out there. So across the board, there's three general main pillars that I would call them. So you have offensive cybersecurity, forensic cybersecurity, and defensive cybersecurity. And across the board, the ones that we generally cover are things like open source intelligence, log analysis, network traffic analysis, cryptography, scanning, forensics, password cracking, enumeration and exploitation, and web application security. So those are the general topics that we cover, ranging, like I said, from offensive to defensive to some of the forensics aspects of it. So we'll actually talk about each one of these things in depth, and we'll talk about some of the tools and techniques for each one of these topics here. Any questions so far? Cool. So the spirit of a CTF at the end of the day, and this is super, super important because a lot of people go into a CTF and kind of like sort of only see it as a competition or sort of only see it from like one particular perspective. So I just wanted to cover a little bit really quick on the spirit of a CTF, which is like, it's this iterative learning process. So the first time that you do a CTF, you might not do particularly well in it. It's okay. At the end of the day, a CTF isn't a standardized test, right? It's not a certification exam. You don't have to pass it. There is no passing a CTF because there is no percentage mark that you're getting. There's no grade for this afterwards. It really is a iterative learning process. So each time you do a CTF, you want to challenge yourself to do better and better and better each time. And as long as you're doing better, that's all that really matters in the spirit of a CTF. So as you are improving yourself, the notion of continuous improvement applies to us humans as well, even though we commonly hear it in the context of like technology. So again, as long as you're continually improving yourself, you're successfully participating in a CTF. And it's really okay at the end of the day to not know how to solve a challenge. There's a lot of things that even us like folks who make CTF challenges, like we will participate in other CTFs as well. And then we'll find out, oh, I actually don't know how to do that. And that's completely fine because then this is a data point that now you know I am not familiar with this particular concept. If I'm interested in learning more about it, I should go and do some research into that area or attend maybe some training sessions or maybe get in touch with some peers who are knowledgeable in that particular area. So again, it's completely okay not to know how to solve it. It's a learning opportunity at the end of the day. And then lastly, all of these things combined together sort of can help you understand your own strengths and weaknesses. So either you can work to improve your skills, or you might say, well, I don't really care about some of these weaknesses because that's not what I'm focused on, and that's okay. So, and that's really at the end of the day for you to choose and decide. All right. So let's talk about the individual skills here. So on the open source intelligence side of things, each one of these categories that I go through, there will be a visualization on the right-hand side to kind of like show you what it's about if you're not really familiar with this particular category of cybersecurity. So with open source intelligence, often people call OSINT. The key thing here is that Google is generally your best friend. There's this concept called Google hacking or Google dorking. If you just literally go onto Google itself and search for Google dork, you'll find some articles that are on this particular topic area. At the end of the day, Google is one of the most powerful search engines that has ever been created on this planet. And it has really just a ton of ways that you can search it and find very, very specific and very, very niche information that you might be looking for. So it's one of the tools that for people doing OSINT, like that's how some people are able to like sit on the other side of the planet and be able to find out like exactly where like a picture was taken because they were able to find some very specific details of the image itself, for example. So, and related to that, on images in particular, there's almost always hidden metadata in images. So when you're taking a picture with your iPhone, with your Android device, there are metadata that is associated with those images. For example, like GPS coordinates of exactly where this image was taken. So if you upload that into certain services, it will upload it with the metadata still in there, and somebody else can download that piece of image, and then they can find out literally the exact GPS coordinates of where that particular image was taken. Most social media networks these days, keyword is most, not all of them, but most social media networks these days do scrub out these GPS coordinates for you, because they understand that not everybody is security savvy or privacy oriented, so they will scrub it out, but not all of them do. So that's one of the things to keep in mind when you're posting images online. So, and on that note, people do put a lot of information out on social media accounts, and a lot of times that is a great source for open source intelligence, because you can find out information about someone's hobbies, someone's interest, and that a lot of the times is used as a part of some sort of spear phishing attack against that particular individual. So if you identify, very trivially, let's say if you identify this person is a dog lover, and you start marketing maybe pet specific, or maybe even specific to the particular breed of dog that the person owns, and then you craft phishing messages centered around that, you might be able to get a very successful phish out of it. Again, that's a very trivial example there, right? So you could dig further into somebody's social media accounts and find out way more about them than just like what kinds of pets that they might own. There are tools like Maltego that you can use in order to organize these different sets of data that you have collected. If you ever seen like those movie portrayals of like hackers, you get like all these like webs of relationships and information like that. That's effectively what Maltego does. It can help you create those like network webs, so you can understand who's related to who, how, in what ways, etc. And you can start to build those like relationships. So if you're getting into like very sophisticated attacks, adversaries, or a pen tester who's been hired will build those things out and then try to find out what's the connection between everybody, and then how can they exploit some of these different relationships in order to get like a successful phish into the organization. Now, that sounds really cool, but if you're doing like small scale OSINT, something like Maltego is super unnecessary, because it's just trying to like get a really large tool in, and most of the times you don't actually need to have that if you're doing smaller scale OSINT. Any questions on open source intelligence? Excellent. So moving onwards onto log analysis. So with log analysis, all you really need to get started on log analysis is something like just a Linux machine, because the Linux command line utilities are in itself super powerful. So you can use the Linux command line utilities for the most part to get a lot of these basic analysis things done. So if you want to just like sort unique, maybe like cut out some columns in there, you can use these command line utilities in order to do that. And that doesn't really require a whole lot of setup. And like I said, all you need is a Linux machine. So if you're familiar or you feel comfortable enough with your Linux foo, you can try these particular commands. If not, obviously get some more practice on these as part of a CTF or as part of like a training program, obviously. So with log analysis, one of the most important things in here is make sure that you enumerate every single data field that exists and understand exactly what they mean and how they can help you. So for a lot of log files, it comes with like God knows how many different data fields in there. And a lot of times we start like overlooking some data fields because we're not really sure what they mean, and or we might think it's useless, but may actually come back being very useful, because it may contain like some sensitive information in some of these fields in there. So you want to make sure that you understand exactly what the fields mean. A lot of the times, programmers aren't the best people at naming variables a lot of the times, ironically. So the field names may end up being super cryptic. You might need to read some documentation in order to find that out. One of the key things with log analysis is that you also want to make sure that you correlate multiple different data pieces together, which is why the point above is super important. So if you understand exactly what the data fields there mean, you can then tie two separate sources of data together by maybe some shared common field. And they may not go by the same name. They might not even go by the exact same format, but if you can do some transformations there, you find the common denominator between the two. Now you can start tying these things together. So like a trivial example might be, let's say, employee badge logs, and then also a computer sign-in log. They're two completely separate data sources, but you can find out maybe there's an employee ID, and that employee ID can be translated to like a username, and then that username is tied to the computer sign-in logs right there. So you can now build a comprehensive timeline of when did somebody swipe in, when did somebody log into a computer, and when did somebody swipe out or log off the computer there, for example. And you can tie these different data sources together in order to find out maybe what went wrong in this particular sequence of events. So at the end of the day, with log analysis, a lot of it is identifying basically what is normal and then also what is suspicious. A lot of times, those trivial examples would be some sort of anomaly in terms of behavior or patterns in the log files. So if you're a company that works 9 to 5 every single day, and then all of a sudden you have people that are signing in at 9 p.m., then that is an anomaly that is outside the bounds of normal. So then that you might deem that as something suspicious and something worth additional investigation into. So moving onwards to network traffic analysis here. So with network traffic analysis, some of you all might have heard of tools like Wireshark, for example. That is absolutely your best friend. So Wireshark allows you to do what's called packet dissection, so that you can actually break down into the very specific individual levels of a packet. So we're talking about, like, if you're familiar with the TCP IP model, it will be able to dissect specifically the link layer, IP layer, and transport layer, and also application layer. And for some application layer protocols, it will actually also be able to drill even further down into it and give you application field dissection there as well. There's another tool out there called Network Miner that can also come in super helpful. I've personally not used that as much, but a lot of my fellow packet heads will tell me that Network Miner is super, super useful. So I trust their endorsement on this, and you can also check that out yourself as well. Very similarly to log analysis, it's a lot about identifying what is normal and what is suspicious. So with network traffic analysis, you will get sort of all of the network traffic in a given capture. And then a lot of the times there's just like normal stuff that's flowing back and forth. And you don't necessarily care about that because you know that that is normal traffic and those are okay. So you want to slowly filter out basically what's like known traffic. So you know that this traffic is something that flows on your network all the time, and this is acceptable. And then you want to then carefully inspect any of the unknown traffic, because that's a lot of the times where data exfiltration might happen. Attackers are obviously getting smarter and smarter these days, and they're trying to blend in more with your known traffic, which obviously makes this job ever more difficult. And like I said, similar to log analysis, get your baseline and then identify any anomalies that might exist there. Any questions? All right. Let's move onwards to cryptography. So cryptography is a very common category that shows up in a CTF because it sets up a lot of the foundational knowledge and skill sets for like how we have cybersecurity as a field today. So a lot of it is based on a lot of these like cryptographic guarantees that we have. So a lot of it might actually seem fairly trivial to you, but a lot of CTFs do include these to just encourage some like foundational skill sets there. Pattern matching skills is an absolute must in this. So if you can identify patterns, if you can identify like the key space of a particular set of just seemingly random characters, that can help you a lot in doing some of these like cryptography challenges. So if you can identify things that are like potentially like headers or some sort of like repeated patterns in this like sequence of seemingly random data, you can then get a lot out of it. So if you want to, if you can identify things like magic bytes out of something, or if you can identify that a particular sequence of hexadecimal letters were just like keeps on being repeated over and over again, that's where you'll be able to find the potential exploits into the cryptographic scheme itself. So frequency analysis, some of you all might have heard of this before, but it's the idea that looking at how often are characters or sequences of characters being repeated, and then sort of using our understanding of the language itself, most commonly, let's say the English language, since a lot of the CTFs are English based. So if you do frequency analysis on English itself, you'll be able to find out like certain letters are constantly reused. The letters THE, the, is used all the time in English. So you want to look for patterns that might indicate to you that something is being repeated too frequently, and that might be something that is known within the English language itself. There's a tool out there that's called CyberChef. It has like pretty much all of the utilities that you need in order to encrypt or decrypt most major cryptographic schemes. So if you're somebody who isn't super familiar with command line utilities, such as like OpenSSL or something like that, CyberChef is the absolute way to go, because all you got to do is like click, drag, and then paste some stuff in. You can even save your work, like the link that that is in your URL. You can copy that, bookmark it, and you can come back and return to your work midway through, if that's something that you were working on. So I love using CyberChef a lot, actually. So if I don't want to fire up like OpenSSL to do something, I'll just use CyberChef, and it's been super, super helpful for me. All right. So next category that we can talk about is something that's
Toby, I have a question, sir.
Yes, absolutely. Go for it.
Can you self-install CyberChef? Well, I thought it's included on Security Onion.
I'm not actually super familiar with what's included in Security Onion, but CyberChef itself is literally just a web app. So you don't actually have to install it. So gchq.github.io/cyberchef, and then here it is. Yeah, okay. So you can do like, AES like encrypt, for example, drag that in. You can start specifying your key IV, your inputs here. So super, super useful. No, actually, quickly, yeah.
Because when I run Security Onion, I see this as attached to that, but I haven't set up the interface for CyberChef. But I've used Kibana and some other sort that comes with Security Onion. But
yeah,
thank you.
Gotcha.
For finding that.
No problem. You can download it. There is a download, so you can run this locally if you would like. I don't know if there's a particular benefit. Maybe somebody who knows can feel free to chime in. But
also a follow-on question with regard to the CTF that is coming on. Would you advise working off from a VM box that have everything like Kali that you might need, or just work on your normal operating system and you should be able to?
Yeah, very good question. So I actually go into this later, but the preview to that is, yes, absolutely install Kali. It'll make your life a lot easier. It also enables a certain level of isolation between your regular computer and then also whatever it is that you're doing for the CTF, right? So generally for us, we don't put anything that is malicious into a CTF, but you might end up with like a CTF that might have some sort of altered version of like a piece of malware that you might be asked to look at. So if you download those things down, if you're very careful with it, you can avoid accidentally executing it, but I always advise people to just put it into like a virtual machine, and then that is the absolute safest way to execute something on a device that you use all the time, because you don't want to accidentally execute something and then now you can't go to work the next day, because that would really suck. So I do recommend doing like a virtual machine. So great questions, by the way. Anybody else have anything? Excellent. So yeah, if you're not familiar with how to use CyberChef, I want to just actually quickly go over this, since we have this page open anyways right now. So with AES encrypt right here, you can punch in some kind of key. So you might like do any kind of encoding for the key. So maybe your key is in English letters. Cybersecurity is awesome, might be your key. And then you might have some initialization vector, IV, so that helps randomizes your encryption outcome. So this could be something that you also do, some secure IV, 1, 2, 3, 4, cool. And then right here, you'll already start to see there's like some basic output coming out. So even if you encrypt absolutely nothing, AES will output something out of there. That's just a result of the AES encryption itself. But if you want to put into the input, hack the airport, for example, right there, you'll see that the output comes out in hexadecimal form right here. So this would be an encrypted message. And you can in turn take this particular encrypted message and you can put it back through the decrypt algorithm here, and you'll be able to spit back out the original text. So we can actually try that. So let me open CyberChef again. So what we can do is type in AES decrypt, drag that in. Similarly, we will take these and then make sure that we have the same keys that are being used. We will copy that in for the key and IV. And then what we can do is take the output right here, copy that, and then put that back into input. And you'll see that in the outputs box here, we have hack the airport that comes back out. So again, this is super, super trivial, but AES sort of as the encryption scheme itself used everywhere. Like our Zoom meeting here, I believe might be encrypted using AES. I don't know the specific protocol that they're using, but it might be AES actually. So it's super accessible to just anybody to be able to do some of these like super, super basic encryption schemes right here. And you can do that all over your browser by just accessing CyberChef. Any questions?
Yeah, hi Toby, can you hear me?
Yes, I can. Go for it.
Great. So I just have a question. If in case we do not know the key that we need to use for decryption, then how can we proceed with those kind of encrypted cryptographic information that we have?
Yeah, very good question. So with something like AES, if you don't know the key, you're kind of out of luck on that one. It's really, really hard to break something like AES without the key for it. Now, if you're doing something that is not AES, so let's say you're doing something that's a little bit lesser sophisticated, like a ROT 13, for example. Let's see what they got here. Let's do so actually let's show this. So there's an XOR. So XOR is one way that you can encrypt data, but it's not a super efficient way to decrypt data. So to encrypt data. So what you can do, there is this thing called XOR brute force. That's a recipe that you can apply within CyberChef itself. So you can have some input into here, and then you can tell it what's the length of your key, and then set some of these other options here. And you can also provide them with some known plain text string. So this is why I mentioned earlier, if you know that there is some data inside the encrypted message, such as like English letters THE for the, you might be able to specify that here. And then what this will do is then start to apply different values for the key and then see if it comes back out with something that is meaningful or not meaningful. So right now, it's trying every single possible 1 byte key. And you can see that nothing in here is coming out to be anything particularly useful because we don't have any particularly useful information in here. So this is one way that you can go about doing like a brute force against it if you don't know what the key is. So let me actually show you a more concrete example. Say it's 02. So here's our encrypted message. So this is hack the airport, but encrypted with an XOR key of 02. So if we take that, we add from hex right here. So it'll take this in, convert it from hexadecimal, and it'll run it through XOR brute force. So you'll see that key of 01 right here, garbage. But key of 02 right here says hack the airport, and that's what we have just entered earlier. You'll see that the 02 right here, that's exactly the key that I have used. So for some, and this is a very key word, for some encryption schemes, And XOR is a very, very poor encryption scheme. Never use this in production, never. But for some encryption schemes, there are ways that you can do brute forces like this, where you can find out, oh, cool, hack the airport. That's something that I can do. So, and then now you know the key to decrypt this message 02, for example. Does that make sense?
One thing
Yeah,
I'll just
thank you.
interject
Thank
for everybody is there's encryption and decryption, and there's also encoding and decoding. So that may also be helpful for the competition when you think about not just cryptography, but also encoding things versus encrypting things.
Yeah, very good point from Matt over there. So things like here, this is like encryption/encoding. So some of these things are encrypt. So you'll see the ones that say like encrypt and decrypt. For some of the other things, you'll see here that says encode and decode. So the very big difference, encryption generally requires a key, and that key is not known to everybody else. Whereas encoding has no key. It's just a scheme to transform letters into some other alphabet, for example. So there is no key. Everybody knows the scheme. So these are purely encoding mechanisms. So for example, things like base 64, these are encoding mechanisms. So if you take something, so let's take that at the airport again, and we do 2 base 64 right there. That comes out as something that looks kind of like seemingly random. It could be encrypted, but here's the thing. If we take this piece of output right here, and then we move that into another recipe, we can just do from base 64, drag that in, and then we paste that in, and we get the exact same output back. And you see right here, I didn't even have to specify any sort of key, because it's just an encoding mechanism for us to represent data in a slightly different way. So these are not encryption. Encryption has a key, encoding has no key. The encoding mechanisms are known to everybody, whereas an encryption key should only be known to the people who are communicating back and forth. So that's a very, very key difference. Thank you, Matt. I believe also I saw in the chat here, somebody earlier had asked, can individuals participate in the CTF? The individuals can also participate in the CTF. If you go in, you will just end up being as a team of 1, and that is completely okay. Once you register, you'll automatically be put onto a team by yourself. And then if you want to work with others, I believe Carissa sent out instructions for this, where you basically transfer yourself from your current team of 1 onto somebody else's team, and you sort of like get everybody to join up like that. All right, so next let's take a look at scanning and recon. So scanning and recon is a very, very useful set of skills to have. The very key thing in this is identifying the right tools to use. So a lot of the times you might be scanning a particular system, and you might need a particular tool for that particular system. So we'll talk about some of these tools here. Nmap, that is the primary one that most people use for scanning. It's what like the Swiss Army knife for port scanning. So if you are just starting off and you don't really know what you're looking for, Nmap will show you all of the open ports that are available on a given system, and even has some additional scanning mechanisms for certain ports or certain kinds of applications in there as well. And then after you scan these ports and you have identified what ports are open, so let's say you got like an HTTP server, you got like some DNS server that's available out there, you might then use a different kind of scanning tool for that was tailor-made for that particular service. So the most important thing here is to understanding how to interpret those results that you're given in the scanning tools, because a lot of the times the scanning tools output things that make sense to the creators, and it makes sense like in the context of the tool itself, and it may not necessarily always make sense to you in the particular given situation right there. So a lot of them, again, very, very specific to the service. So you might need some additional in-depth knowledge about the service itself in order to interpret some of those results, which often just ends up leading to some on-the-spot learning right there. So again, like if you get an HTTP server, but you're not super familiar with HTTP protocol, the scan results might not make a whole lot of sense to you, and you'll need to get to understand the HTTP protocol a little bit more sort of on the spot there. Excellent. If we have some time in the end, I'll also go back and do some additional demos. I just want to make sure I get through all of this before our time is up here. So on forensics, so forensics is super interesting as a category. Personally, one of my favorites. So very, very similar skill set in log analysis and network traffic analysis, but just ever so slightly different. So what you're doing in a forensics type of challenge is identifying what information might have existed at some point in time, and you're looking for the existence of them, and then you're going to extract that out. So one of the very common things that you might do is looking at some sort of physical media. So we're looking at like a hard drive or like a flash drive, for example. When you delete a file on those things, it's not technically deleted. So when you hit like, the delete button on your computer, it'll come over a confirmation screen saying like, are you sure you want to delete this? You can't ever get it back anymore. That's kind of fake. So you could technically get it back if you tried hard enough. So when you delete a file, what it's doing is not actually erasing the file from your disk, because that actually takes time, right? When you're copying a file onto your disk, you got to wait for it to like do its whole copying thing. And then because what it's doing is writing all that information to disk, but your deletes just happen instantaneously. And that is because when you hit delete, what your operating system does is just makes a mark on the file that says this file is now deleted, quote unquote. So don't show it to the user, just tell them it's gone and it's missing now, right? But just somebody who's a forensic analyst, what they can do is read the raw data off of your hard drive or off of your flash drive and be able to read the original file back in and then recover it in its entirety. So that's the reason why when we're copying large files, it takes a really long time. If we ever wanted to delete them, it's almost instantaneous that it happens because your computer is kind of lying to you. It's not really deleting it. It's just marking it as deleted, meaning that this space is now available for use. And so the next time that somebody writes another file over it, your file will get overwritten anyways. So that's kind of how that works. So if you ever have worked in any sort of like secure or classified environments, you'll know that digital media goes through very extreme measures to make sure that data is thoroughly destroyed. So a lot of times it involves writing the data over and over again for like up to 9 times in order to make sure that all the data has been completely overwritten. And they really want to get rid of some data, they will physically destroy the disk after they've overwritten it like 9 times. So that is why some of those policies exist, if you're ever wondering. So there's a couple tools that can help you with this. One is Autopsy. Autopsy is sort of almost like a Swiss Army knife. It's not as versatile as probably everybody would like it to be, but it can do a lot. So it can help you recover deleted or also sometimes corrupted data off of your disks. There are certain limitations to Autopsy, like the kinds of file systems that you can use. But for the most part, like say a Windows file system, NTFS, Autopsy will be able to read that through just fine, and it will be able to recover pretty much any sort of deleted files off of your drive. I've actually personally used that before because I accidentally deleted something and I actually wanted it back. So I've actually used the tool itself to recover some files personally rather than use it in a professional or a CTF sort of environment. So that can also be a useful tool for maybe yourselves sometime in the future. There's another tool out there that's called volatility, and that is a piece of tool that can be used to analyze RAM memory. So when you have a piece of application running, they store like temporary variables and pieces of data, maybe sometimes even things like encryption keys or decryption keys for that matter, inside of your RAM, because it's generally assumed that no one's going to be able to like access your RAM. So it's a kind of a safe spot to put it. But if you're able to extract RAM from a computer, you will then potentially be able to read these temporary variables and potentially these encryption and decryption keys out of it. And so a tool like volatility can help you sort of navigate through RAM memory, because a lot of times it looks pretty random and it's literally in the name itself, random access memory. So the the tool there will be able to help you make sense of the information that's in RAM and then help you extract like maybe the encryption key out of RAM so that you can use it to your advantage later. All right. So we also got something that's called password cracking that we see very often. DEF CON also one of the largest cybersecurity conferences every year has a password cracking challenge as well, where they give you all these like password hashes and you just kind of crack as many as you can. So super exciting. A lot of people participate in it. So we'll talk a little bit about that. So with password cracking, there's a really common misconception is that you just need like the most powerful computer in the world, and that's really the best way to crack your passwords because you're just throwing as much brute force to it as you possibly can, and that's really the best way. But that's not necessarily always the case. If you know something or anything about your target, you can narrow down the amount of space that you're searching for by effectively doing some OSINT, for example. So if you're trying to break into a particular person's account, so again, in the legal context here, in the sense if you're doing penetration testing, for example, if you're trying to target somebody's password, you will find out some information about them through open source intelligence. Again, maybe it's their pets, maybe it's their vacation home, maybe it's their interests, hobbies, etc., their favorite team, all of those fun things. So you can now curate a word list to search in that particular word list. Maybe this is how they crafted their password. So if you get to know a little bit more about this person, you can then start to do these word list attacks against them rather than purely brute force attacks. So the way that passwords work, if you're not familiar, there's something that's called cryptographically hashed. So the cryptographic hashes aren't reversible. So what that means is that they're one way. So you can take like plain old English, turn it into a hash, but you can't turn that hash back into plain old English because there may be multiple different things that map to this exact same hash there, for example. So you are not able to reverse it as you might do with like an encryption or decryption algorithm. If you have the key, there's just no way to reverse it. So the only way for you to do it is through brute force. So brute force applied on top of a wordless strategy will narrow the amount of words that you have to search. So instead of searching like all the possible combinations of letters, numbers, and special characters in the universe, you're now limiting yourself to a smaller set of here are words and letters or numbers of interest, and you're searching only in that, and that will significantly reduce the amount of time that you are brute forcing something. That can be something that is very helpful as a technique. There are two primary tools that I personally like to use. There's something that's called Hashcat, and then there's also something called John the Ripper. They can crack most common password hash formats. Some of them do a couple other password formats. Some people also like there's another tool out there called OPHCrack, OPH crack. I don't use that myself as often. Like my go-to is generally Hashcat for the most part if I'm doing anything password cracking related, just because that's the one that I'm most comfortable with. That again, it's entirely at the end of the day what you know the best or what you're most comfortable with. A lot of them will do very, very similar things there. Oh, and then there's an additional tool called AirCrackNG. So AirCrackNG is very specifically used to crack Wi-Fi passwords. So if you ever have a piece of like network capture for Wi-Fi traffic, you can apply that into AirCrackNG and use that in order to crack Wi-Fi passwords. So I actually learned how to do that when I was about 12 years old. I was waiting for Comcast to show up to install like my internet service, but I was really tired of waiting, so I went and found out how do I crack my neighbor's Wi-Fi password. I ended up just asking the neighbor to borrow it. It seemed like much cheaper, much easier way to do it. But in the process, I ended up learning a little bit more about how do you crack Wi-Fi passwords. So that was kind of fun. All right. Next, we have enumeration and exploitation. There's a couple of different things that get sort of covered in this. A lot of the times, the category will also be called something like reversing or reverse engineering. So at the end of the day, it's trying to reverse engineer some sort of software code. For the most part, it's software. And then you're trying to identify possible exploits and weaknesses in the particular piece of code. So because it's software code, so your knowledge of C, Python, Java, JavaScript, Ruby, etc., all of those things will be super, super advantageous. If you don't know code, you are sort of at a disadvantage there. So this is one of those like very, very hard and strict like prerequisites. You must know some knowledge of code in order to reverse engineer code itself. So that's something that I would highly recommend to get a little bit more comfortable in. You don't have to become an expert in it. Like literally a Code Academy course on any of these languages will probably suffice in order to get you like the groundwork for it without like getting like a whole computer science degree or something like that maybe. So once you are comfortable with code itself, you will also need to get comfortable with another really steep learning curve of a tool, which is something like GDB. So GDB is the GNU debugger. So what it will do is it will attach onto compiled software like C software. And what you can do is step through it, understand what are the variables that are currently being used, maybe what are some of the instructions that are available in the actual code itself. And then that leads me to another sort of language that you should be familiar with, which is assembly language. So that is the assembly instructions that your CPU actually ends up executing. So a lot of this, as you can see, gets like very, very low level, very, very quick. If this is not an area of your expertise, don't force yourself into it. It is a super interesting field. There's not a whole lot of people out there that do this well. So I myself am somebody that has dabbled in this like quite a lot, and I don't really like it, but I know how to do it is one of those like interesting kind of things. So I don't like to do this very, very often myself either. But if you're interested in this kind of area, there are a lot of companies and government agencies who pay very, very top dollar for these kind of skill sets. So again, if you're familiar with things like assembly language, how to do GDB, those are very, very valuable skills to have. If you don't know, there is sort of a way to get around it. There's something, there's a bunch of different tools out there, Ghidra, Binary Ninja, etc. So the one thing I wanted to actually cover mostly is Ghidra. So that is a piece of tool that is developed by the NSA. So if you click on this link and click on download from GitHub, you'll find out that it is National Security Agency on the header there. So this was developed, like I said, was developed by the NSA, and they have since open sourced it, so you can go and download it. If you have feelings about the NSA, run this in the virtual machine. That's okay. But it is very, very powerful as a piece of tool, because what it will do is not only just take a piece of software and then show you like the assembly language for it, it will try its best to decompile back into C code. So it will try its very best guess at what the original C code might have looked like. So instead of looking at assembly language, you are now looking at C code. So if you're somebody that is more familiar with C but not as familiar with assembly, Ghidra will absolutely help you make more sense of it than before. So this part, I found this particular tool to be super, super useful, and is like stupidly powerful. Definitely give it a try at some point. It does require a little bit of a learning curve, but I would absolutely recommend that you give it a try. All right, lastly here, we have web app exploitation. So this is, as the name suggests, exploiting web applications. The web is one of the most ubiquitous types of technology that we use these days. And so there's all sorts of different ways that you can break it. So let's talk a little bit about that. The main technique here is identifying how user supplied input can lead to sort of some unexpected behavior on the particular web server. What that means is that as a web server, you are constantly getting user input. So whether it's like a search on the website, it's a form that somebody has to fill out, or it's like, even maybe accepting payment or something. At the end of the day, the user can provide you with something that you were never expecting to handle ever. So if you're, let's a very trivial example might be you only accept Visa cards on your website, but then the user all of a sudden put in a MasterCard, and you didn't test this out, and you didn't make sure that something wonky wouldn't happen with a MasterCard going in. That is an unexpected behavior on your web server now. So, and that's something that a user can potentially take advantage of, because then your code doesn't know how to handle MasterCard, and then it goes off on a completely different path than what you had originally intended. That's at the end of the day how most of these vulnerabilities happen, is that you coded it for something, and then the user decided, nah, we're going to do something else. So that's pretty much all security vulnerabilities that happen these days. Some of the most common ones is SQL injections. You've probably heard of that before. There's a couple other things called local file inclusion and cross-site scripting, which are also major concerns relating to web apps. So all of these things can lead to unintended sensitive data disclosure. What that just means is that there's some sensitive data that's being stored on the server, and then now you have accidentally disclosed it. So SQL injection will be able to force the database to read out information that wasn't privileged to the attacker, maybe, and then now you're left with your database essentially exposed to attackers. So with web app applications, some key knowledge of JavaScript, Ruby, PHP, and also the SQL query language itself can be super advantageous. JavaScript is used both in your browser, and a lot of the times these days actually used on the server side as well, because everybody is moving towards a framework called Node.js. So you'll find that very commonly in web applications these days. Ruby on Rails is the other dominant web application framework that's being used these days. PHP is a little bit older, but still very major companies such as Facebook still use PHP. And SQL is the query language that helps you access database records. So those are all very advantageous languages to be familiar and know about. There are a number of different tools that you can also use for this: Burp Suite, Z Attack Proxy, and also Postman, which is a Chrome extension, the last one there. So all of those tools are great. They all do phenomenal things. I do web app exploitation all the time myself, and I actually don't use any of the three tools that I've just recommended. I myself actually use the Chrome Developer Console. So because the Developer Console is meant for the developers to track all the requests that are going in and out, but that in itself actually becomes super useful in an attack scenario. So if you open up the developer console, so a lot of us know that as like right click, inspect element, for example. So you will be able to open up the developer console here. Not only will you see like just the elements that are on the page, you can switch over to the network tab. And so if you are switching around pages, you'll see that these requests get logged in here. So you'll be able to actually go in, click on each one of these requests, see what are some of the, let me zoom that up a little bit, see what are some of the request headers that are sent out, what are some of the authentication, etc. All of these fun things that go into there. And this is something that you can absolutely use to your advantage in order to break a piece of web application there, for example. So I'll close that. And then in the interest of time, Kali Linux, absolutely install this. It comes with all these tools that we have just talked about: Nmap, Wireshark. We didn't talk about Metasploit framework as much, but Burp Suite and the Z Attack Proxy are pre-installed, Hashcat John the Ripper pre-installed, AirCrackNG pre-installed onto there. So you don't have to go and download these things individually yourself. And like I said, putting it into a VM is going to be the best way to ensure that you are isolated and you are safe when you're participating in these cybersecurity competitions. So
awesome. Thank you so much, Toby. And speaking of some of those tools, we did have a number of trainings. So we had Metasploit yesterday. We're trying to get those videos uploaded to our YouTube channel. And then later today, we have Wireshark and Nmap, where we'll go a little bit deeper. I just thank you both for your time, and thanks everyone for joining. We look forward to seeing you tomorrow. Registration for the CTF is now closed. And that's just so that we can have time to put teams together. But you can email WiCyS.CIC. So it's WiCyS.CIC@gmail for some last minute consideration. So thank you all for joining us.
Excellent. And I think somebody asked for the slides. I posted that into the chat right there. If anybody wants to download a copy of that, by all means, go for it. And then Courtney, are you all keeping a copy of the slides at all, or?
Yeah, we're collecting all the material, so we'll share that as well.
Excellent.
All right.